Thanks, guys. So I'm going to be telling you the story of how we did that, what Peter just said. We built the Formula 1 fantasy game in under 2 months. But first of all, I want to tell you what Play On is and what Daily Fantasy is, for those of you who are not familiar with it. Daily Fantasy product is, Daily Fantasy Sports platform is the main product of Play On. We operate games daily for a whole variety of sports, including football, cricket, basketball, motorsports. And the format of the game is, an example here, it's a football game, so you will pick a fantasy team based on a budget of 100 million. And then based on the performance of those players in the real life game, you rack up points and compete against other players that pick their own teams. And you have an entry fee into a game and a pot at the end. Depends on the payout structure, you get paid depending on your position. So that, on a very high level, is what Daily Fantasy is. So then, Formula 1 approached us as a company because they were looking into a company to build a fantasy product for them for a season-long game, which is what we built. And they identified and Play On the values that they wanted in a partner, and there was good synergy between us, and then we went ahead with building the Formula 1 fantasy game. So the challenge was, we would need to start building before the contract was signed, because there was a lot of bureaucracy and a lot of small bits that needed to be worked out in the contract. So enable for us to be able to launch the game before the season started, which was the objective of the first MVP. We needed to do it before the contract was signed. So there was a leap of faith on our side. Started building that before the contract was signed. We expected 150,000 users on the first season, registered users. We would leverage the existing game structure that we have for the Daily Fantasy, which includes, I'm going to talk a little bit more about that in another slide. It needed to be an independent system for hosted on the Formula1.com domain. We were going to use Ruby on Rails on the backend because that's what we already use for the daily product, and also Ember.js on the frontend, also because we're very familiar with that. And we also use it on the daily product. And also, one very important feature of this is that it needs to be reusable for future partners that we're in conversations with. So if we want to launch a season-long game for another partner, we can reuse the structure. And of course, the first partner using this is Formula 1. This is the URL where you can play the game. So talking a little bit about how we built the backend, one point on that before, I forgot to say before, Lee Farrell works at Play On as well, and he's going to talk a little bit about the challenges we had on the backend. So the high level stuff is that we decided to use a Rails engine instead of creating a new app or adding bits to the application on the daily side, because the Rails engine is like a plugin, so we could do it entirely separate from the logic of the daily game and still use all the features and all the foundation that was there. Then we created a namespace on the API exclusive for the white label operations, creating teams, picking players, saving your teams, and all the operations that happen there. We use the same feed processing engine that we use in the daily. This is what gives us the events that happens in the race. Position started, position finished, pit stops and all of that. We use the same engine on the daily and on the white label. The API was built leveraging the structure like users, teams, feed processing, which helped a lot in being able to do that in 2 months. If we needed to build all of that, we certainly wouldn't meet the deadline of 2 months. And we also built the league boosters, which I'm going to talk a bit more about next, on top of what we already have. So, over to Lee to talk about the backend.
Yeah, so as Rafael said, there was an existing code base there, and we basically built on top of that. There was a couple of features like leagues and boosters. Boosters are like you play a wild card, it means you can change your full team in the game week without taking a hit. And leagues were just you play in a league with some of your friends. These were features that we didn't have in the daily game, so thought the cleanest way to do that was to make a Rails engine, which is basically like an embedded Rails app inside the main Rails app, and what we did was for all the controllers, we would just inherit from the base controllers and then add functionality into the new controllers as we needed. One thing being like authentication. We had cross-site authentication, so F1 would send us users with a token, and we would decrypt that and use that as a way to tell who these users were. So that authentication mechanism is different to the one that's used in the daily site, so we did that by overriding the controllers. So yeah, some of the interesting problems we had, I'll talk about scale in a minute. To build leaderboards was actually very difficult. You didn't, for the daily site we built leaderboards in real time, and if you haven't got that many entrants in a game, it's not so difficult to order all these entrants. But when we're talking about a global league of 170,000 users, you need to do this in batch and store it somewhere. So it actually went through a couple of iterations where we would just store the top 100 in Redis, but we actually need to show every user their position in every league that they're in. So we landed on a solution where we have a cron job that runs every, I think it's 6 hours, and it will iterate over all the leagues. It pre-calculates the full leaderboards for all those leagues, and then for every entry in the league, it will insert into Redis the details of that entrant and all of his positions in all of his leagues. It takes about 40 minutes for this cron job to run to populate one league leaderboard for one race. So the whole job takes quite some time, which is why we had to space it out over 6 hours. But it means that when a user comes to the site now, all their positions are basically just a lookup in Redis, so it's extremely fast and scalable. One of the next interesting problems we had was, so we have a live page which shows all the events that come in for drivers as the race is happening and the points for your team update in real time. We decided just to use polling for this. I mean, we could have used WebSockets, but I've just found polling in the past to be very reliable. That would have meant that everybody was polling the Rails server, I don't know, say 5 seconds for, we get a lot of traffic. Like, how many would we have during a race?
5,000.
5,000, so yeah, to have 5,000 concurrent requests coming into a Rails app at any one time to try to get player scores it's a bit of a problem. So again, we just use caching there. We use Redis caching to cache all the player scores. We return a full list of player scores to the front end, and then the front end can calculate which players it's actually interested in, and it will sum them up and sums up your team score then at the end. We have plans actually to make this an even higher throughput by adding Nginx as a reverse proxy there. So you just use the HTTP cache headers to tell Nginx to proxy to cache this response at different levels along the network. So you could use something like a CDN to cache the JSON for that endpoint at like a country level or whatever, and you just provide some code in the Rails app that tells Nginx to create a public cache. And then that means then that all the polling requests don't hit the Rails app, they just hit the Nginx, and that's optimized for really high throughput. Another interesting problem then was transition in game weeks. So the existing system, we had to reuse that as much as possible. So one way for us to get from one race to the next was we create a game for each race, and then we had to copy every team over from one race into the next. And that was a massive job as well. We've got, as I said, 170,000 teams there, and we can only transition when we know the results of the race, because the prices that get input for the next race depend on the results. So we needed this to be extremely fast from the time we put the prices in to the unlock happening and allowing people to choose their next team. So we do this by, we've set up Sidekick with multiple queues. We've had to use multiple instances of Sidekick, and in each instance of Sidekick we have multiple queues. The reason why we have multiple instances of Sidekick is, if anybody knows Ruby, they know that there's something called the global interpreter lock, and that stops Ruby from executing more than one thread on the CPU at any one time. So how you get over that is you have, if you've got four cores on your machine, you would have 4 instances of Sidekick running. And again, we have more queues in there, which allows to, like the app is very I/O heavy, so it means if you've got like 4 queues running, if one of those block on I/O, the next thread can come in and do its job in the database while the other one is waiting on I/O. So yeah, scaling. I've actually never worked on an app that required so much work to scale. How we did it was we used New Relic, and we just looked up the endpoints that had the biggest throughput, and we could see there clearly what was going on at the database level. And we would just iterate here. We would add indexes where they were needed, and then look at New Relic again. We would use a load test tool called flood.io. Was it? I think Rafael will talk about that in a minute. So to get to the 170,000 users and have no scaling problems, we just used Redis. We have what did we use? Object Rocket on Rackspace we had, which was like a high availability, really optimized version of Redis for exactly for something like this. And in the daily code base, we've got a gem called Active Loaders, which is actually now deprecated. But what it does is helps you to get rid of the N+1 queries. So I don't know if anybody's aware of what they are, but it just means you load one record, like say a blog post, and then you have to do a separate query to get every single comment belonging to that. So yeah, the Active Loaders gem meant we could do a lot of eager loading there, and it helped us get to a really fast product. So yeah, that's kind of all I have to say about the technical side.
Cool. And all of that was done in later on than 3 weeks? First pass?
Kind of a roundabout, yeah.
Okay, so that's the backend, which is the heavy lifting. The frontend was a fresh Ember.js project. We started it from scratch with new designs. Everything was new in the frontend application. It was built in parallel with the API development, so we could, if something was missing from the frontend or we needed to change something, and it had such a tight deadline, so there was no way it could be different. Of course, it's responsive from the first version. And the last area, which is DevOps, we use Rackspace at the time. The structure in general lines is one load balancer for the API instances. There's auto scaling. So we have 4 baseline instances to serve traffic on load times, and up to 20 plus 1 instance that is the image for that on auto scale based on response time. So if the response time goes up, we spawn new instances. Well, theoretically, we could have used Passenger Enterprise to start that, so we could use less servers and more concurrency on the same server using the cores. But we were not sure our application is thread safe, so we decided to not take that risk. One other really important aspect is that we decided to use the same database as the daily game. So we went in the configuration of Postgres, we tuned everything that we could find. We're not experts in Postgres, so it was kind of a discovery process. We made it a lot faster than it was before. It was supporting everything very fine. And for the front end, we have a single Nginx server handling everything. As it's a JavaScript application, it's easily cacheable, so a single server is enough. So then we finished the MVP at the last day of the deadline. You're probably familiar with last day stuff. The contract was still not signed, so we couldn't launch the game. There were details being worked out. So the launch date was pushed for about 3 weeks. Was it 2 or 3 weeks? And then in that time we decided to do load testing. For that we used a tool called Fluid.io, which sends as many concurrent users as you want to test. And then we figured out that we had a lot of performance issues that Lee was talking about, all the optimization we did. We optimized pretty much every single endpoint that we had. We were running everything under 50 milliseconds, actually under 100 milliseconds average. And in parallel with all that optimizing, we were doing the passenger configuration, Nginx configuration, everything, the network configuration in Rackspace. It's a lot less self-service than AWS, for instance. So there was a lot of work going on there. And also new front-end features and fine-tuning also was happening in parallel with that after the original launch date. So after almost a week of load testing, we believed we could support 6,000 concurrent users. We reached that number because this is what we see on the reports from the Fluid.io. So this is basically the cutoff point where the requests start getting slow. And this is about 6,000. So we were confident that we would be able to hunt at least 5,000 without any problems. We launched the game on April 25. In the first 24 hours, 36,000 people signed up. There was good repercussion on the media and social media, Reddit and all of that, so it was amazing to launch something that was very viral. But not everything is blue, so I was away in vacations it was 3 weeks after the original launch date, so when I planned my vacations I thought it's going to be fine, we're going to have it all worked out. So I was in Brazil, race time approaching, so traffic going up, the database can't handle it. The database went down, we started it, went down again. It was desperation time, so we came to the unavoidable conclusion that we do not know how to configure Postgres properly, and our instance is not going to be able to handle that. We were confident that we will make it based on the testing. Based on this, we were confident that we wouldn't have any problems, but of course there are stuff that you don't predict. So all that happened on a Saturday morning at 8 a.m. So now I'm going to tell you the story of that weekend. We were planning before launching the game, we were planning to move our database to RDS, which is a AWS service, managed service for Postgres, so you don't need to worry about all the configuration, and they give you the very best throughput you can have on that type of instance. But of course we had only 2 months, so we didn't have time for that. And Saturday 8 a.m., the whole database offline. Nobody able to do anything. The site went down. We restarted, it went up, went down again. So what do we do, right? We had the idea of moving to RDS already. So at 8:10, I came to the conclusion that this was our only solution to the problem, because I wouldn't like to spend a weekend trying to configure Postgres at the end of the weekend it doesn't work and we don't solve anything. So we decided migrating to RDS. Then I started by trying to use the database migration service that AWS provides. So I spent the whole Saturday trying to make that work. Before it would even begin working, I would need to upgrade the Postgres from 9.3 to 9.4. So I did all of that on a test server we had. And Sunday morning, still I couldn't make that work. So I went to a desperation measure, tried to dump and restore, which, if for those of you who know Postgres, never works in the first time. And for some miracle it worked in the first try. I moved the staging database that we had, tested data integrity and everything, replicated the same process on the production database, moved all the instances to point to that new database, and by Sunday 9 p.m. everything was fine again, running on the RDS database. So after that we had healthy load balancers, healthy API, lower memory, usage on peak, all wins on that, faster response times. And then this is a little bit after the launch, but afterwards we moved all the structure to AWS, not only the database but everything, the load balancer, the instances, Redis. So everything is on AWS on the same data center, so it's really fast between the services. And the game is running fine. So now we have 172,000 players. This is about the number we get for peak times before and after the race weekend starts, about 5,000 to 6,000 concurrent users. On Rackspace we needed 25 servers to be able to handle that. On AWS we have a bit less than that, more distributed. We have smaller instances on AWS as well. We have 100,000 unique visitors per month and about 82 million requests served by the API. This number is not only the Formula 1 game, this is the full API. And also one important detail, after we migrated to AWS, we split the database. So if we have any problems on the Formula One game with traffic and something going down, we don't affect the daily side, because on the original weekend, it wasn't only the Formula One game that was down, it was the Formula One game and the daily game, so everything was down. And now we split that, so that we have their independency. Talking a little bit about the next steps now, that we're 2-3 months into the game, 170,000 people playing. This is a sneak peek of the next version, which is being launched in the next few days. So we're going to be able to see that. You're going to be able to have 3 teams, not only 1 team, which alone had its own challenges. I think it would be a topic for another presentation maybe. But in the future we're going to have promoted leagues, which are official leagues for partners and for, say, the Twitter Formula One. They want an official league for the Twitter fans, so they can do it. Up to 3 teams per user, custom start leagues, meaning that you can create a league not necessarily in the first race of the season. You can start it mid-season or whatever race you want. Recommended leagues, which will recommend to you leagues. We use Elasticsearch also to track player stats and activity, login, sign up. That's all the track right now. Yeah. And also in the future we're going to have new partners, new scaling challenges, new features, and specifically for Formula One we're going to have a new predictor game, which hasn't started yet, but probably that won't have a 2-month deadline, I hope. And that's it. And by the way, we're hiring front-end developers. If you know someone who would like to work on something like this. That's it. Questions?
Excellent.